flipping the classroom. Now, just jump in at any time. Leave your mics on, and try to keep this as conversational as we can. And you're all familiar with flipping, the basic concept of flipping, right?
I would say.
Did I start the recording? I just want to make sure because we forgot it a couple of times. I didn't forget it, but someone did. Okay, good. We are recording. Okay, so flip classroom, very quickly, is we take a classroom and we flip it. Basically, the approach is, sorry, that was kind of bad. This is one of the variants of Bloom's taxonomy. And one of the questions we could ask is what do most lecturers focus on in the classes that focus on lecture? We're seeing that less and less, but in lectures, where do people generally focus in terms of Bloom's taxonomy?
I think probably at the very basics, right?
Usually at the basic levels. There's a lot of discussion of basic definitions, basic relationships, and very basic level concepts. In a traditional lecture class, what would happen is that students would be asked to do the higher level things on their own often. The things that students find most difficult is not learning the basic definitions or the basic concepts, although sometimes they struggle with that. But more typically, though, it's when they try to apply the things, when they try to take the basic concepts and transfer them into other areas that they face the most problems. And in a traditional class, that would generally occur on homework assignments or on papers or on an exam. And by then, it's a little bit late, perhaps. So the flip approach, in its very simplest form, is to have students do the basic level knowledge acquisition outside of the class. They could do readings, they could watch videos, they could be ones that you put together or ones that you just link to from other sources. And you acquire the basic level knowledge outside of the class, and then you use the class time to focus on the things that involve higher level activities, that involve applications, that involve the types of things that students find most difficult and where they can most benefit from your assistance. So that's the basic structure. And there's a lot of techniques that are used. Any number of active learning techniques could be used for this, but I just want to mention a few of those. One is team-based learning. This is actually a very formal approach. It's been written up. It's trademarked. And there's a whole series of things that they do. But basically, you divide the class up into small teams that are persistent under this approach throughout the course of the semester. And you give them some reading assignments. They, in class, they'll first, often, let me back up a step. The typical approach is you would take a general quiz to assess prior knowledge. Then you would provide some sort of a short introduction. It could be outside of class or it could be in class. And then the students work in teams. They take various quizzes, where first they take the quiz individually, and then they do it as a group activity. That usually involves those little scratch-off cards. Many of you have probably seen those or heard of them. And that's a fairly structured way of doing this, and it works really well. Bill Goff, who was here a few years ago, used this. We had someone in the School of Business use it. And I don't know if there's many people who use it but on our campus, but it is widely used, and it seems to be remarkably effective. There's also problem-based learning approaches, and this goes by a number of different names. This is used a lot in STEM fields, where you give, and in others as well, but you give students a basic problem, and then you have them work to develop the skills they need to solve the problem. It's often structured in such a way so that they start with very basic level skills, and then they move up to higher level skills where they're learning things as needed. And it helps provide a little bit more motivation to find ways of solving problems. Sometimes there's a whole class structured on this. Sometimes there's specific activities.
Can I interrupt you for a second, John?
Anytime.
For the problem solving portion of it, do you give them the problem ahead of time, or they see the problem for the very first time in the class?
It could be done in a variety of ways. I mean, in some cases, a whole course will be focused on this. For example, some community-based learning is focused on problem-based learning. One of the things we talked about in our podcast was something that was done at Hobart William Smith, where they have actually a 2-semester course that works with this, where the first part of the first semester, they work with the community to identify problems in the community, and then they spend the rest of the semester building a system to address those problems with the community in a way that's ongoing. So that could involve any number of things, but it could also be something where they're asked to design something. If you're teaching, for example, in tech classes, in vocational technology, they might be asked to come up with a design for a better propeller or some other item, and then they spend the whole semester picking up the skills they need for 3D modeling in order to design it, and then 3D printing and other types of approaches that will allow them to solve the problem, where basically they're learning as needed to do a particular task. In engineering classes, this is often used as well. Or it could be a sociology class, or it could be an economic class where, for example, you work with the community to address income inequality or food insecurity, and you look at what tools you need to address those issues, you develop the skills along the way, and then you apply them in some particular application. It doesn't have to be community engagement. It could be you structure a problem and you tell students to try to find a solution, or you ask them to come up with a way of analyzing chemical composition or something, and then they have to learn how to do analyze spectrums and so forth to get to those solutions. So it could involve experimentation. You could give them a problem of measuring something and then let them develop the skills they need to do that, where they go out and they learn as needed, basically. Actually, Doug McKee has done this a bit in econometrics with his classes, where he gives them topics that they have to do some analysis of an issue, but they haven't yet developed the statistical and econometric tools, and they have to learn them basically in order to solve the problem. And he scaffolds that quite a bit too. Just-in-time teaching is a really simple way of doing this, where you give students, there's a lot of variance on this, but the key is you have students do the basic learning outside of class, and then you do some type of testing in class to see what they know in real time. It could be based on a reading quiz and so forth. Okay, I see there's a question here. I'll get right back to that. But with just-in-time teaching, basically, you let students do the basic knowledge acquisition outside of class, and then you ask students to either with a quiz before class, it could be a reading quiz that you do online, or it could be using clickers, for example, in the classroom, where you have them work on some applications and you see how they're doing. And then if you find that they understand it, you don't waste any more time in class going over it. But if you find that students are not understanding something, you spend your class time focusing on ways of helping them acquire, of scaffolding the knowledge. So that if you find they can't do a higher level task or problem that you've asked them to do, then you go back and you build it up, where you give them some lower level tasks. And once they've mastered that, you move to a higher level task, and so on until you can go back to the problem and have them work on it. So the key with just-in-time teaching is the time that you have them work in class, it doesn't have to be lecture. It could be just a sequence of problems you have them address in small groups, for example, so that they are able to do the higher level problems. But you focus just on the things, you come in with fewer preconceptions about what they're going to have to work on, or what topics you need to cover, and then basically you build it just in time to address the needs that they have, which could come about either with you looking at their results before the class, or it could be based on real-time feedback and so on. So there you have to come into class prepared to go over a wide variety of things. But when you've been doing this for a while, and even just a few times, you generally have a pretty good idea of what types of things that students need assistance with. Now, there was a question in chat. Let me get back to that. I accidentally closed that. And now I'm having trouble getting to it. Let me pop out for just a second. And why am I not? Okay, here we go. The chat is just not coming up at the bottom for me now.
I can actually ask the question.
Oh yeah, that's easier, yeah.
This is Naja. So one of the challenges that I'm finding when trying to apply the flip model is I know that my students, I mean, many of them admit that they do not do the readings prior to class. And so I'm going over the content during the class time, which then limits how much time I have to do the activities, such as what you mentioned. How much time should I realistically spend going over content in lecture? And how much time should I, allot for the flip piece of it, the activities?
That is a really problematic issue that we often fall into this trap of, and this is one of the problems we have, which is one of the reasons why people encourage flipped classroom, because we get into these cycles where we tell students to do reading before, and then we expect to be able to go over it, but they come in unprepared. And then what happens is we get into this vicious cycle where we start going over things that we had asked them to do, and then they come to class and they say, oh, if those students who had done the reading and so forth come into class and see that you're going to discuss it anyway. And because of that, they do even less reading. So what a lot of people suggest is that if you're going to flip the class, you should flip it entirely and not do any of the very basic level things, and train them so that they do come prepared. Now, that's easier to say than to do, because you often find if they get to a point where they can't do anything, you don't want to just sit there, but you you have to do something to address those issues. But there's some simple things you can do. One is having that quiz before they come to class and have it due before class time is one strategy. And I've had them do that before, but not everyone did that. And, they took the lower grades on those quizzes just so they didn't have to prepare for those classes. I did something really simple this fall semester that worked really well. I used I had them do the reading and I asked them to do the quizzes too. But I also had them do a little reflection. It was due just a few hours before class, where I just asked them 2 questions in the Google form. The questions were, what did you learn from this reading? And what are you still confused about? And most students, nearly all students, did that. And the interesting thing is they came in much better prepared than they had before I did that, even though they knew I'd be focusing on. I used clicker quizzes for most of the class. Even though they knew that they'd be quizzed on this stuff in class, they'd be working through problems on it, many of them still didn't do the reading. But just that simple task of having them do that little reflection on what they understand and what they're still confused by seemed to get them much better prepared. And I saw some significant improvements in performance. So what a lot of people will do is they insist that they're not going to go over basic concepts and they'll focus on applications, but you still do have to build up some of the basic concepts for students at times. But the mix is difficult in practice. And there's always a temptation to start doing more lecturing and falling into that cycle where you keep scaling back the higher level activities and spending more and more time on basic level activities. And that tends to be a self-reinforcing cycle. I had done much of that myself, where I would do some short lectures in class and then have them go through problems, like 5 or 10 minutes of lecture on a topic, then a question. And this time I just focus on the questions and problems. And then when we go over the problems, then I'll give some assistance if they're stuck. But usually I'll try to get other students to draw it out. And when they can see that other students are able to answer the questions, it lets them know that, or the students who haven't been as well prepared know that other students are in fact coming to class better prepared. And it does create a little bit of peer pressure to be better prepared in the future. I wish that worked universally, but it has been. Cutting out pretty much all pre-prepared lectures, at least, seems to have helped eliminate that issue where students come in having not done, or where most of them did come in having at least attempted the readings and worked through the problems. I'm not sure if that helps, but it is an issue. Any other thoughts or reactions? I was doing a mix, and then we did a podcast with someone from University of North Texas, and he just suggested, well, he used the phrase in for a penny, in for a pound, and the basic suggestion was if you're going to flip the class, it's probably better to do it. Now, the other issue is that many students don't want to speak in class. They become more heavily dependent on Kahoot and other tools, and that's often true. And in fact, if you're teaching a large class, a lot of students are reluctant to speak. But you know, using quizzing things, using clickers, using Kahoot, at least lets them take some rest without as much pressure, because it's from the standpoint of the rest of the class, it's anonymous. Even though you can see whether they got it correct in your grade book and they know whether they got it correct, it's a whole lot easier to participate with mobile devices and so forth rather than talking.
But you could also, I assume you could also have them respond as a group.
And that's a nice, safe way of doing it. You could have them break up into groups. Now, since I often teach classes of 300 to 400, that's a little bit harder. But in smaller classes, you can have them work in groups of 3 or 4 and then have a group response. And people are often much more comfortable responding for the group than stating their own opinions. That's a good idea. And whenever I go over problems, I do have students present their solutions. And usually there's enough people in the class so that there are people who are willing to do that at any time. But a lot of students in larger classes just are really reluctant to speak. And unfortunately, in a really large class, you don't really have time to let all of them speak, which is a bit problematic. But okay, so the main point of this, of just-in-time teaching, is focusing your class time on the things that they struggled with after they've done the basic level work, but getting them to do the basic level work is an issue. And students respond to incentives in ways that are not always very rational. If you just make something work, I have activities in my class that are worth 5% of the grade, and it occurs every class day. So each class day is a tiny fraction of a point. They get really upset if they miss any of those. So, you know, even though the probability of missing one of them, of that affecting their course grade is vanishingly small, they still get concerned with it because they don't want to miss points. So, you know, some low stakes incentives can often help encourage students to come better prepared to class. Okay, another tool you can use is project-based learning. That's, in practice, I kind of mix that together with the problem-based learning. What I said before for problem-based learning was actually a mix of project-based learning and problem-based learning. Project-based learning is where you have a complete project. For example, some classes in engineering will design some type of thing to put into a competition. Design classes will sometimes compete in design competitions or other things. But where you have some sort of project where students can use their skills is useful. And I kind of conflated that before with problem-based learning. But in either case, having students learn to complete a task where they have an incentive to do well in the task tends to motivate the learning much more effectively, whether it's to solve problems or to complete a project. Peer instruction, it's already been talked about a little bit, but when you have students work in groups, that can generally involve peer instruction. Even when you use clickers or polling, most research suggests that the best practice there is to combine that with peer instruction as well as some just-in-time teaching. And the most common practice is to ask students a question, have them answer individually. In large classes, it's really hard to get them to submit individual responses and not talk to the people around them, but have them at least try to think about their solutions individually. And then after they voted or they submitted it, let them work with others and then resubmit. And during that stage where they're working with the other students, what I normally do is the same strategy is a strategy developed by Eric Mazur, which is to ask students to find someone who had a different answer and try to convince the other people that their answer is better, and then listen to their explanation of why they think the other answer is better. And the nice thing there is that on any given set of questions, there are going to be some students who understand it better than the others. And what you'll almost always see is a convergence towards a correct answer in cases where there really are correct answers, at least. But what happens is the students who don't understand it as well can benefit from having the explanations given to them by other students who have developed a somewhat higher level of understanding of the concepts, but they're still at a level of cognitive development that's comparable in some way, so that they're able to explain things to other students in ways that are more consistent with their level of development of their conceptual understandings, conceptual frameworks, than instructors tend to be. Once we become experts at a field, when we see a problem, we can very easily classify it. We can very easily come up with and identify the set of tools that we need to solve the problem. Students are not at that level, and it's much more of a struggle. It requires much more cognitive processing, and other students who've just gotten to that point are much more effective in explaining to each other how to do that. And for the students who really have mastered it, trying to explain a concept to students who don't understand it is a really good way of reinforcing your own understanding, because you have to be able to put it in words that other people can understand, and that's a really good way of learning. I think many of us, when we first taught intro-level courses, really came to understand the concepts much better than we ever did when we were students, because we have to be able to explain it to people who may not always understand it at the same level. And and the same thing works when each student is actively working to explain it to each other. So there's a lot more processing going on. So those are just a few of the basic techniques. Just to emphasize the importance of this, one of the interesting cases of this was done at San Jose State. They paired with the edX MOOCs. It was an experiment that only lasted a couple of years. There was a lot of controversy there, particularly in some of the humanities department, and eventually they were able to convince a college to drop it. But one experiment that they used was in a circus and electronics class, which was a class at San Jose State, as in many schools, that tend to have a really high drop, fail, and withdrawal rate. And what they did is they paired it with a MOOC on circuits and electronics, so that everyone who was taking the class signed up for the MOOC to learn the lower level skills, and they spent class time going entirely over applications. So they flipped the class by having students take the MOOC to acquire the basic concepts and the basic skills and knowledge they needed, and then they had class time spent just to work on applications of that. And what happened was the original passing rate was 51%. So 49% of the students either dropped or failed or withdrew from the class. And then after they paired it with the MOOC and they flipped the class, the instructor and TAs, the same mix of people who had been there in previous years, just went around and worked with students in small groups. And when they did that, it was a 91 student class. The new passing rate went up to 91% with the same instructional staff. And the only difference was that students signed up for the free MOOC and they learned those basic skills outside of class, and they spent class time working on applying the concepts, the types of things that students have the most trouble with. So that's kind of one of the more exceptional cases, but it does suggest that the approach can work. Eric Mazur in physics, many of you have probably heard of his work there or seen videos with him. He was here a few years ago. One of the things he noted, using the forced concept inventory, where he tested students before using a flipped classroom approach or a flipped approach with clickers, and after. It was a controlled experiment where he had, in one class he uses, in others he didn't, or he had, well, in any case, what he found is that the learning gains were nearly triple when he used a flipped approach, when he had students work through clickers and peer instruction, than when he had not been using that approach. Carl Wyman, along with a few others, found learning gains of slightly over double in terms of the difference between the pre and the post-test scores. And the whole distribution in each of these studies shifted significantly to the right when they introduced flipped learning. And pretty much all of the studies have done this. Now, just want to mention what I've been doing in this many years ago now, because I've been gradually flipping the class more and more until I completely flipped it this past fall. The median student in most of our introductory courses on a test called this Test of Understanding College Economics, a nationally normed measure of basic economic instruction. It's used a lot for research on teaching and learning. And the typical student scored somewhere around a 50th percentile. After I flipped the class, even way back like 7 or 8 years ago when I first started doing this, and Bill Goff and Liz have done very similar things, a typical student at the end of the term is most often in the micro class has been at the 75th percentile. It was a little lower last time. I think it was somewhere around the 65th percentile. But the whole distribution, again, is significantly higher. And a lot of that seems to be from having students do more of the work outside of class, where they do some readings, they watch some videos, they take some quizzes outside of the class, and both Liz and I at least use a form of mastery learning quizzes. I let students take some of the quizzes an unlimited number of times with random drawings from them each time. Liz, I think, allows 2 attempts at the quizzes at each of those shorter quizzes. And then we have some other quizzes that are somewhat higher stakes. The way my class works is students read the materials first. They then do that reading reflection quiz where they talk about what they understand and what they don't understand. And those quizzes they can take again and again for higher grades. But then when they get to class, they take clicker quizzes where they get some points for correct answers, but they also get some points for incorrect answers for just participation. So it's not terribly high stakes. But then at the end of each module, they have to take a test. They only get 2 attempts within my class, and then they get to the midterm and final where they only have 1 attempt. So the stakes get progressively higher, but they're given a lot of opportunities to make mistakes, to learn from the mistakes, and do better. And it is a lot more work for students, and the more work students do, the more they learn. But in general, we've seen some really significant performance gains with it. So that's a very quick overview of what I've been doing with this, but the research on flipped classrooms is generally really positive. It's used really extensively in the STEM fields, but it's been used in a lot of other disciplines as well with quite a bit of success. So questions, comments, reactions, thoughts? And I'll open up the... That's a really quick introduction. And yes, measurements that students may complain in teaching evaluations stating they have given too much work. And yes, they do. And yes, students do complain all the time about it. The 2 types of complaints that I get the most in this class is first, that this is way too much too much work for an intro level class. And in my case, maybe it is. Liz has a little bit less in her class. But I see the large learning gains, and I've got tenure, so I don't have to worry about that so much. The other complaint that students will have is you're not teaching me, because they're really used, especially freshmen, they're really used to going to classes where they are lectured to. And when you don't do that, a common response that I'll see on their evaluations is, he makes us learn it all ourselves. And the basic problem is I can't really do the learning for them, but they don't always see that. They're used to going to class, listening to a lecture, and then just reproducing some recollection of that on a quiz that they found for right before. But learning is work. And if you really want to have students learn material that they're going to be able to use in long term, it really helps to give them lots of retrieval practice. So yeah, but if you're not tenured, you probably want to be really cautious with this. And you really, no matter whether you're tenured or not, it really helps to get some student buy-in on this. And it really helps to emphasize that you're doing this not because you want to give them a lot of work and make their lives miserable, but because the more they work on the material in your class, the better they get at it. And it helps them learn it so that they'll be successful, not just in this class, but any other classes that build on this class.
I guess motivating why we're doing that, it's key. It's important.
And talking about the research, showing some of the results can be really helpful. And I find that I've been doing that more and more every year, and I'm getting more and more buy-in, but it's never complete because students have come through an educational system where they generally haven't dealt with many flipped classrooms before. But you do want to motivate it, and you want to explain why you're doing it, and let them know they're doing it for their benefit, basically.
Exactly. I think it also helps if we somehow, or at least I will try this semester to show to them that they're lifelong learners, and learning doesn't stop once you end up a semester or a year of college. You will learn on the job oftentimes, and I think if at least we're pointing them towards this possibility and actually this reality, I think they may be a little bit more inclined to embrace this style of taking.
And also often, before I do this, I'll ask them a little bit about what they do in terms of studying. And what most students do in terms of studying is they tend to read and reread again, and they tend to highlight. And, I show them, I'll send links out to studies and some short videos, which suggest that those strategies tend not to be very effective, So breaking their illusions about how they learn and helping them see, what we know about how people learn can be helpful. And there's a lot of really short videos where people talk about the benefits of retrieval practice and so forth. And you can even ask them for examples of how they learned in other areas, other aspects of their life. And you can often make some connections there where they'll see that, they got better at sports, or they got better at playing music by practicing it. And, if we want them to be better at being able to apply the things we're trying to teach them, having them do more practice is helpful. But yeah, the lifelong learner thing is something that I think more and more students are starting to recognize, that jobs are changing, technology is changing. A lot of jobs that are really popular now may very well be replaced with artificial intelligence and other things in the future. And,
even nowadays, jobs require learning, because you might need to get acquainted with the new market, with the new type of customer, with the new software, with the new process. It involves learning all the time. And the idea is to have this habit of learning with you.
Mm-hmm. Yeah, and I think more and more students are seeing that. And if you can put it in a context that they can recognize, that really helps. Yeah, you can talk to them about, or ask some of them about the jobs that their parents have or their grandparents had, and how many people are doing similar jobs today, and and how those jobs have shifted over time. But motivation, is really, really important. And if students buy in, it helps. And just on that, one other plug I'll put in for today's podcast, that's something that Michelle Miller talked about quite a bit in the podcast we released this morning, where one of the things she does is whenever she does an activity in class, she explains why she's doing it. And she mentions trades off class time to do more retrieval practice types activities in class. She also uses Kahoot, and she'll spend the last day or so before a final exam going through Kahoot quizzes with her students, and having them do it as a class activity, and saying, there's these other topics that I'd really like to cover, but it's more important that you understand and have learned the material we've covered up to this point. So we're going to sacrifice some class time and going over new material so that you can reinforce your knowledge of this. And something like that could be really powerful too. Other thoughts, reactions, questions? No? Okay, well, we'll stop this session and we'll start up again if anyone wants to come back and just talk about how you can do some of the flipping, some of the tools you can use and so forth.